You're watching the New Stack Makers, a podcast for people who develop, deploy, and manage at-scale software. For more information and articles about at-scale technologies, please visit thenewstack.io. Now enjoy the show.
CrowdStrike has redefined modern cybersecurity with our advanced cloud-native platforms for protecting endpoints and cloud workloads, identity, and data. CrowdStrike's adversary-focused approach to CNAPP provides agent-based and agent-less solutions delivered from the CrowdStrike Falcon platform. Hello, everyone, and welcome to the New Stack Makers. I'm your host, Heather Joslin, features editor of the New Stack. In today's episode, we're going to talk about something pretty scary, the rise in cyber attacks that are focused on the cloud. Your cloud specifically, the one where you're basing your distributed architecture and the one where you run your critical applications and data. The latest crowd risk report from CrowdStrike shows an alarming rise in cases of adversaries targeting cloud environments. They've nearly tripled from 2021 to 2022. See, told you today's episode was going to be scary. We'll link to our previous coverage of the report in the notes accompanying this podcast, but to learn more about the nature of today's cloud-focused threats and how to protect against them, we're joined by Elia Zaitsev, Global CTO of CrowdStrike. Welcome, Elia.
Hi, Heather. Thank you for having me.
Thank you for joining us. And before we begin, we want to thank CrowdStrike for sponsoring today's conversation. So let's get started.
Let's do it.
All right. So, Elia, first of all, what makes a cloud environment so hard to protect?
Well, I don't know if it's necessarily hard to protect in and of itself, but it's different. It has unique opportunities and benefits, and it has, unique challenges and circumstances. So I think, first of all, it's new. It's something that a lot of individuals who have maybe been in security, InfoSec for years, for decades, they've gotten very used to doing things one way. And well, now the game has shifted a little bit and people are playing catch up. So that's part of it. I think as we evolve as an industry and people, come into the business and they start with cloud and that's kind of their natural habitat from day one, it'll be a little bit less of an issue from that regard. But there are also some fundamental things about the nature of cloud. Again, it's a double-edged sword. It can cause benefits, but it could also cause issues. And one of that is the scale. Mm-hmm. In the old days of on-premise hardware and servers, if I'm an application developer and I want to build something new, someone's got to physically bring in boxes and set them up and plug them in. And I've got to work with a bunch of teams to do that. And of course, all of that gives me an opportunity, if I'm doing it correctly, to build a process and a program and do it the right way with security by design. And one of the reasons why developers love the cloud so much is because A, it makes things quick and easy. B, you can scale to crazy levels, really quickly, as long as you've got a big enough credit card to keep adding on the infrastructure. But also, in many cases, especially if you're using like a modern DevOps program and paradigm, it lets the developer who's writing the code also set up the infrastructure and the configurations of how it talks to each other, the security rules, firewall, the software it's running. And this is a very powerful technique from a developer perspective. It's called infrastructure as code. Mm-hmm. It means that I can determine and design the entire environment along with my application. And the way it operates on my developer laptop is, or it should be the same way it operates when I push it to the cloud. And that's all great if you do it the right way. Of course, if you make a mistake, if I don't understand how to secure it properly and I put a wrong configuration in my infrastructure as code, and then I go put it in the public cloud and I say, run 1 million copies of this, now I've just introduced that same mistake 1 million times over, and there may not be any other teams, departments, processes, limiting factors getting in my way to stop me from doing a bad thing that I don't realize.
Yeah, so if you unlock a door, you're not just leaving one door unlocked, you're leaving potentially a lot of doors unlocked.
The whole neighborhood is unlocked, right? The whole city is unlocked now.
Yeah. Well, I want to talk about misconfigurations and how to prevent them a little later in our talk. But you spoke at CrowdStrike's recent summit about how there are 3 kinds of attackers: the cloud conscious, the cloud capable, and the cloud comfortable, which I understand is a term you coined. Can you describe what those categories mean and how they play out in terms of threats?
Yeah. So that that interview that you mentioned, I was doing it with a coworker of mine, Adam Myers. He's our senior vice president of threat intelligence. So I don't know if he coined it or if it's an existing term, but he had talked about cloud conscious and cloud capable, and we were kind of spitballing, and I came up with this third term on the fly. I'm not a marketing person, calling it cloud comfortable. So yeah, let's break it down. I guess it's really all about the maturity and the sophistication of the attacker, the adversary, when it comes to operating in that cloud environment, that cloud domain. If you start with the cloud conscious adversary, and again, these are, as far as I know, unofficial terms, but it's pretty common sense. A cloud conscious adversary knows that many organizations are going to be running some or all of their workloads, have their data and infrastructure and systems living in the cloud, and they know to look for things. They're going to check if there's misconfigurations, and it's just something that they're going to do as part of their day-to-day, if you will, of looking for mischief and mayhem to cause, data to steal, et cetera. Cloud capable, you're kind of moving it up another layer. You're not just familiar with the fact that there is this thing called a cloud, but maybe you're treating it as just a different place to host, traditional servers and applications, but you're aware that there's unique capabilities, unique threat models, unique risks that the cloud pose, and you're more actively pursuing them. Then you kind of get to this new area, this emerging area that again we kind of made up on the fly during this interview, that we call cloud comfortable, which is when you're not just aware and you can do some damage, but it's actually your preferred vector. It's kind of like what we talked about a second ago. The cloud is new for everyone, right, including the adversary. But just like on the defensive side, we have a new generation of individuals coming up and entering IT and security that are basically being born in the cloud. You're going to have the same thing with adversaries, right? They typically, unless you're working for a nation state organization, they're not checking your age and saying you've got to be 18 and meet child labor laws to go be a hacker, right? So we've got this new generation of adversaries that are coming up, and they totally get the cloud and they implicitly understand what those risks are. And again, because of that scale that we talked about, the ability and the risk of, hey, if there's an issue in one place, it might be scaled up to many, many systems. That's actually their preferred attack vector, because they know if they find an issue that they're comfortable exploiting, they can actually much more rapidly achieve their actions on objective, cause damage, make financial gains on their side, cause pain to the end user, et cetera.
What is it about how infrastructure folks work and how developers work and how they do or don't work together that makes it hard for them to collaborate on cloud security?
Yeah, it's a great question. It's not that it has to make it hard. And I've seen it done right in many organizations, but I've also seen it done wrong. First of all, there's cultural issues at play between your infrastructure, your developer individuals, and your security team. Not just cloud security, but security in general. If you think about a typical stereotype of a infosec practitioner, they're paid to be paranoid. They want to do things slow and methodical and deliberate and make sure you're going through all these processes and doing things secure by design. Right? They don't want to be bolting it on after the fact. When you think about how developers tend to operate, especially if they're used to the speed and flexibility of the cloud, everything I just said, is anathema to them. They want to go as quick as possible. They don't want to be told, hey, you need to build something this way because it's the safe way. They want to do it the fastest way, the most efficient way, the most scalable way. And unfortunately, sometimes that can be, directly opposed to doing things securely. So that's part of it. The other is what we talked about a little bit earlier, where in the traditional kind of on-premise world, you have to work with security and other teams to take your code and then progressively move it to the different systems and get it deployed out into production. When you think about those, infrastructure as code paradigms, that DevOps mentality where that developer can put the whole thing together from start to finish, they can now move quickly. And if the security team isn't aware, right, if they don't have an opportunity to engage, you're left with, this tension where the developer is happy with what they built, and the security team is kind of left trying to catch up and say, no, wait, you forgot to do this, please include us. Another reason that this happens, again, doesn't have to, but we see it from time to time. Again, cloud is new. So you have new organizations within an actual company. You have new teams, new departments spinning up, that don't have that security integrated from day one. And maybe they don't have the relationships. There's politics involved between the new shiny thing and the older legacy thing. And that can cause tension. It doesn't have to happen, but we do see it frequently.
The report, which we'll link to in the notes accompanying this, and you who are listening to this can go read it at your leisure. Found that attackers are getting better at avoiding detection. What are some of the ways they do this?
Yeah, in many ways, it's not that different than what we've seen attackers do and increasingly doing on the on-premise infrastructure. The cloud doesn't make it any different. Typically, what they want to do, or the most effective way for them to penetrate an organization, is to pretend to be you. So things that we've heard about before, like social engineering, right? Get the credentials of an administrator and then log in as an administrator. That's a lot stealthier than trying to send somebody a spearfish and convince them to click on a malicious document, which typically isn't something you even think about in the cloud, right? You're not really hosting your laptop in the cloud. You're running your server applications. There's no one there to click on emails, right? So you're looking at misconfigurations. You're looking to compromise credentials. You're leveraging the fact that those credentials might be reused in a much wider environment, for example, or they have overly permissive privileges. So that's really what they're trying to do. They're trying to look like you being the legitimate user, the legitimate administrator. And that's the most effective way to escape and avoid detection.
TNS have written a few stories, and we talked so far in this about how attackers initially gain access through existing credentials. Are organizations issuing too many credentials in general? And if so, what are some of the ways to tighten up security around this?
I actually don't know if the issue is that there are too many credentials. Certainly, when you have this very scalable infrastructure, you could do things maybe in a suboptimal way where everything gets its own, unique thing, its unique account, its unique password, and maybe that's a bit, needless, and there's extra ones running around. But I think the bigger issue is kind of what I touched on a second ago, which is the permissions associated with those credentials. So like
authorization as opposed to authentication, or
yeah, right. So one of the things that we're always recommending, myself personally and CrowdStrike in general, and most security practitioners, is to practice, the principles of least privilege. Don't set up an account that has more access than what you need it to. And again, if you think about the unique qualities of the cloud, that's more important than ever, right? If I have an account that is, overly powerful and I can touch, 10 servers at home, that's very different than, like a master administrative account in the cloud that can touch 1 million endpoints and has too many privileges. So I think that's overall, the bigger issue that I'm seeing, not the number of credentials, but the power that they have. And this kind of gets back to, I think, your first question of, why is the cloud hard to protect? Again, it's not necessarily harder to protect. And in fact, there's some big advantages to the cloud. The cloud infrastructure providers, this is their job, right? It's all about their brand. It's an existential risk to them if they're shipping, insecure by default clouds. They've got a lot of financial incentives to get things right out of the box. So actually, what you see in cloud is usually you start from, in many cases, a more secure standpoint, but it's so secure in many situations that if you're not used to the cloud, you go up and you try to run an application and you can't do anything. Nobody can talk to it because it's so locked down. And then again, if you're maybe a developer not working with a security team, not used to doing things secure by design, you want to get things running as quickly as possible. So what's the easiest way? Well, open it up to the whole world and give it the most privileged set of credentials. So I don't have to worry about carefully analyzing what is the minimum set of abilities that this account needs to do the job. Much easier just to give it access to everything. But of course, then If I forget to lock that back down and I ship my product into the cloud, well, now I've got this possibly one credential, but it has way more privileges than it needs to. And I think organizations need to be regularly doing this kind of ongoing hygiene and assessment, looking at all the accounts, the credentials that they've created in their environment, and doing that regular assessment of, is this really what they need? Can I dial it back a little bit and be a bit more secure? I think the other thing we see in the cloud, which not unique but more prevalent in the cloud, is it's very easy to leak credentials. For example, I may have an application that I developed and it needs to have some credential to access some sensitive system. And maybe I accidentally stick that file in like a storage system, like an Amazon S3 bucket that I forgot to restrict to only certain users. I've left it open to the world, or I've built these plain text credentials into my application, into the artifacts of the application, instead of doing it the more secure way using a proper credential management system. So now if an attacker can somehow compromise that application, maybe a vulnerability or a misconfiguration, one of the first things they'll typically do, especially if they're not just conscious but capable and comfortable, is they're going to look for those credentials and then say, okay, what else can I do with these credentials? And then you combine that with them having too much privilege. Well, now you can see you've got some trouble there.
So one takeaway: don't hard code your credentials into your applications and your code.
Correct. Never do it, and there's almost never a good reason to do it, other than it being quicker and cheaper and lazier. Right? It's definitely an unforced error that you can avoid.
We talked a little bit about misconfigurations. The report found that 38% of the observed cloud environments in the study were running insecure default settings from the cloud providers. Obviously, that's an unforced error right there. What are some of the best ways to sort of best practices, I guess, to avoid misconfigurations?
Yeah, so there's, I think about
that can make your cloud insecure.
Sure. So there's probably, depending on who you talk to and how you categorize it, there's, I'd say, three principal typical ways that you can address it. Now, I think, and I'll go through those in a second, and I think that the mistake that a lot of shops make is that they'll rely on maybe one of these methods because it's quicker, cheaper, what they're more comfortable with, et cetera. But I think this is one of those defense in depth concepts where you want to use all of them. You want to have multiple layers of defense. But let's go back to what those techniques are. And it basically, you can look at it as where it fits along that development and deployment process or pipeline, if you will. There's this concept they talk a lot about in cloud of shifting left. So if you go all the way to the beginning, right, if you're looking at how does one build an application in the cloud? Well, step one, you write the code, you design the infrastructure, often using code, infrastructure as code techniques. So you have an opportunity when you're first building that code and when you have those configurations built into the code to do an assessment, do a scan, do an audit before it ever actually becomes physical or virtual hardware and say, hey, do I have any misconfigurations there? You secure code analysis, things of that nature. Then you have the next step, which is, okay, we wrote our code. Maybe we did some assessment, maybe not. We turned that code into actual infrastructure, services, virtual machines, et cetera. Well, now you have another opportunity to do an assessment, a scan, monitoring of what those settings are when you initially create the environment. It's very similar to doing it at the code level, but again, you shouldn't assume that you've caught every mistake at the code level. You should be looking and analyzing at what the actual state is of the environment. And then there's the third aspect, which is kind of the continuous real-time monitoring. So I have a misconfiguration, perhaps. Maybe I have a tool to identify it. Maybe it's something brand new that nobody knows how to catch, but there's still the actual system itself. And I can instrument and monitor that system in real time, similar to what we've been doing, for years. CrowdStrike's flagship technology, Falcon's next-gen AV and EDR technology, designed to do exactly that. Regardless of how the attacker gets in, a misconfiguration or vulnerability, let's make sure that if they get through the perimeter, if you will, that we've got almost like a camera inside the house, right? Looking for the burglar moving around. And again, as I said at the beginning of this response, I see all too often organizations will put all their eggs in one of those three baskets, when I think the correct thing to do, the smart thing to do, the resilient thing to do is to use all three of those in concert. Give yourself the maximum chance for success.
So the full life cycle of the not just at build time, not just at
Every full life cycle that's a perfect term for it, right? End to end, from creation to deployment to ongoing, operations.
Yeah. To which of those three stages do you find organizations are most likely to fall down in? Like don't follow through in scanning or.
Well, when you're talking about cloud specifically, it's kind of ironic. I find that it's that last piece, the runtime piece, which we've gotten so good and we're so focused on in our traditional computing environments. It's like second nature. Yeah. How you'd be crazy to run a system, a sensitive system in your corporate network and not have some sort of real-time monitoring. But remember, we have a bit of that cultural misalignment, this new paradigm of cloud. It's this very ephemeral concept of, hey, I have this microservice or a container. It spins up, it's up there for 15, 20, 30 minutes, and then it disappears. Why would I need to look at it if it's only alive for 30 minutes? Well, that's 30 minutes when an attacker could have circumvented your other controls and settings. And don't you want to know what they've done during that 30 minutes, right? Just because you erase the system doesn't mean they haven't stolen data or something of that nature. Doesn't mean that you don't have a million other systems with the same identical settings that are just waiting to be exploited somewhere else. So for many reasons, that seems to be a part that gets a little bit less attention in the cloud world than it does, in the traditional on-premise environment. But there's no reason it should. I think it's equally as important. If anything, it might be even more important because of that ephemeral nature of cloud. I don't have a disk to go pull and do forensics on after the fact to try to piece together what happened. Real-time monitoring in many cases is the only way I'll ever know if and when and what happened in those environments.
So another takeaway, just runtime observability matters. Runtime security matters.
Yeah. If you wouldn't run a system in your corporate network without real time, why would you do it in your cloud environment?
We've talked a little bit about this already. You mentioned a flagship product of CrowdStrike, but what is CrowdStrike's approach to the problem of cloud-focused attacks, and how does it help protect against them?
Yeah, so I think we've got two key things in our approach, and they kind of touch on what we just talked about. One, we not only do we offer capabilities in our platform for all three of those steps, right? The full life cycle, from scanning a container to it's a technology that the industry calls cloud security posture management, or CSPM, looking at how the infrastructure, once it gets deployed, how it's actively configured. And then, of course, the runtime security, that's our bread and butter. That's our claim to fame. That's where we got our start with things like EDR, XDR, next-gen antivirus. But I think what we do that's a little bit special, unique, in our secret sauce is two things. Number one, we do it all in one platform and one system. And we haven't bought like a couple different technologies and we've stuck them side by side, and you've got one screen to do this, one screen to do that. We unify that entire view. So an analyst can look at a single pane of glass and they can see, hey, I have a misconfiguration over here. Did that misconfiguration, was it leveraged by an adversary to do something? Or conversely, hey, I can see through real-time monitoring that there's something weird going on in this system. Great, CrowdStrike blocked it, but is there a misconfiguration I should be looking out for that allowed the attacker to get there in the first place? So that holistic view is one. We're also really big proponents of the multi-cloud paradigm. And that's another area, I forgot to mention this earlier, that can trip up organizations working with the cloud. It's very rare that you're working with one cloud. Usually you've got many. It's very common that you've got, Amazon AWS, Microsoft Azure, Google GCP, and other providers. And now you're asking a security team, hey, not only do you have to become an expert in this new cloud world and you have to understand the correct settings for this one vendor, but guess what? You're going to be working with several others who have similar but different technologies with kind of the same sounding name. But is that really the same thing? It's crazy to some extent that you expect teams to be able to handle this all. Well, that's what we do, for example, with our cloud security posture management. We focus on the ability to operate in all the clouds and kind of aggregate and normalize it. So we can just tell you in one instant, in one snapshot, hey, you've got a misconfiguration in this database service, whether it's, from Microsoft or from Amazon, we'll figure that out for you. You just focus on the fact that there's an issue and here are the steps you want to take to resolve it.
And that's a wrap. We'd like to thank Elia Zaitsev for joining us today from CrowdStrike. Thank you, Elia.
Thank you, Heather. It's been a blast.
Likewise. And we'd like to thank CrowdStrike itself for sponsoring today's conversation. And we'd like to thank all of you for joining us. This has been Heather Joslin for the New Stack Makers, and we'll see you next time.
If you like this video, please give us a thumbs up. And if you'd like to see more videos like this, you can always subscribe to our YouTube channel. We're on all the major social media platforms. You can always find us at thenewstack.io. We hope to see you soon.